I'm going to share my screen. Okay. So you have this. So first of all, don't submit to me a 5 to 10 minute video. I don't want to watch a 5 to 10 minute video. Give me 3 minutes tops. Um, I got 30 some odd people in this class. Um, 10 minutes is 300 minutes. That's a lot of time. That's like 5 hours. So 2 to 3 minutes. And basically, what this is, um, ignore all this stuff. Uh, what I want you to do is I want you to pick a website. Any website is fine. I'm going to go to brandonsanderson.com specifically. I'm going to go here to, I want to go to where he sells stuff. Okay. So I'm going to go here to where he sells stuff. So all I want you guys to do is make a 2 or 3 minute video for me. Pick a website that is not incredibly hard and tell me what you think the back end would look like. Last week you talked about what tables were and how tables talk to each other. So, and this assignment has two purposes to it. One is to give me an idea of where your understanding of what databases look like are. You may have been doing this for a very long time. This might be your first database class. So I just want to kind of gauge your knowledge on how much you know about what databases look like. And the other one is it's so we don't have to use Proctorio. Proctorio is a third-party monitoring software that we used to require twice a semester for you to dial into and take a quiz on camera. So someone's watching you, and you got to provide ID and prove who you are. So instead of doing that, what we're going to do is this, because in order to be accredited, we need to have you on camera doing something proving it that it's you. So we choose this. So please make sure to legit. The only way to fail this is to not do it or not use your camera. So, because here's what it is. This is my version of what this assignment is for you guys too. Hey, Brother Stevic, it's me, Brother Stevic. We are today. I'm going to talk about the Dragon Seal website, and how I think it's set up. It's a shopping site where you can buy stuff related to Brandon Sanderson. And as I look down here, I see a couple of products here, but I've got this button over here that says View All Products. So I'm going to click on that. So I see these products here, and then I look here, and I've got based on different series. I've also got here the shop, the catalog for all products, and I got a bunch of different products. So I think what this looks like on the back end is I think there's a table for products, and there's a table for types of products. So like there would be like a table that would the table of products would have like Alcatraz 6 or Alcatraz signed or defined. These different things would be in there, and then I think there'd be a different table that would be linked to that would have one of be called and these would be the entries in this in the types table. It would have a ID column and a type column, and these would be what Leatherbound Books, Euro Sanderson. These would all be the types that are there. There would probably be a there would be a table for series, and these are all the series that would be there, and they would link up together. So in the products table, in the product table, there'd be like an entry for um, Bastille versus the Evil Librarian hardcover, and then it would be under the type book, printed book, and then it'd be under the series Alcatraz versus the Evil Librarians. Um, Obviously, there's on sale and sold out, so there would be choices there about on if the product is on sale, and there'd be a sales table because I'd want a separate table for that because if they're I don't the sale isn't gonna last forever, but I want to track all the sales that we've had, and there'd probably be a column in the products table whether it's sold out or not. The products table would have different things like signed. Um, uh, Actually, you know what? I might have there might be a different table, and I would might call it embellishments or something. So like, so there's like or extras or something because hardcover would be there, signed would be there, foil printed would be there, something along those lines. And yeah, so and even though like these are books and these are pins and this is a poster, they would all go in the products table. They would just be linked to other tables to say, this is a pin and this is a figure. Yeah. So that's pretty much how I think it looks in the back end. Thanks for listening, and I'll see you on Tuesday night. Bye. Okay, and that then you hit stop, and that's the assignment. So again, not super difficult. Just like I said, just talk me through what you see. You don't need to pull out anything. You don't need to draw any diagrams. This is a very, very simple, easy assignment just to get you start talking about databases and how they're built. And that's it. So there really you should be there shouldn't be any kind of consternation about this. Do you guys understand the assignment?
Yep, yep, I understand.
Yes, I do.
Excellent, excellent, excellent. Okay,
Thank you.
no problem. I just don't want anyone to worry about these things because they're very simple. I was telling, is it Emmanuel? What do you go by? Kissy Emmanuel? What do you go by?
I go by Kissy.
Kissy? Okay. I was telling Kissy that this 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 course isn't challenging, but it's interesting. So I want you to be. I mean, it's also going to be very approachable. So I don't want you to be, you know, frustrated by any assignments. So ignore all this. And the other good thing is, like, I know who hasn't watched the assignments because anyone who does this and gives me a 10-minute video is not paying attention to what I say, and they do extra work, which is their choice. We have free agency for a reason, right? All right, cool beans. So let's go to the fun part of the evening. Let's talk about code, which is what I like to talk about. So last week when we talked about code, I said there were two basic languages. There's actually five total, but there's two that we talk about here. We talk about DDL, which is data definition language, and DML, which is data manipulation language. Data definition language are the commands like create, alter, and drop. These are the commands that are used to create the database, to create the tables, to create the indexes, to alter them and get rid of them. You don't delete a table, you drop a table. Okay. We're going to talk about these later. In the data manipulation language, you've got select, insert, update, and delete, and truncate. Tonight, we're going to talk about select because select is where everything begins. Select is how you get the data out of the database and put it into a format that the customer or your person looking at the data can understand. Because if we're using the Sakila database, which you all should have, if I write select star from customer and I run that, it gives me everything from the customer. And this is not something I want to give the customer, the people who look at the database, because what does active mean? What does address ID mean? Where's that coming from? I don't want these things. I don't want them to have these things. So the entire purpose of of my select statements is to take this data and put it into a format that the people who are using your database can understand. And I don't want them writing their own queries. I'm going to write the queries for them so they can see what they need to see. So select star, when you use this asterisk, it means just show me everything. Just give me everything that's in that table. And here we are. Everything with every line, the whole kit and caboodle is here. But I don't have to do that. I can, in my select statement, I can request specific columns from the table to be shown. And let me show you this fun little cheat because you'll need this later. If I'm here in my tables and I've got my customer table and I go into my columns, here are all the columns that are in here, right? So I can do this. I can do give me last name, throw a comma there, give me first name. Now, this is why we don't use the CLI and we use the workbench because it's drag and drop. And I don't know about you guys, but I type, I am a horrible typist. So the more cheats I can do to not have to type, the better it is for me. So so here I just did select last name, first name from customer. I have all these other choices I can make. I run that. And guess what? It just shows me that. Right? So that's handy. But here's the problem. I've got these in two different columns. What if I want a first name, last name, and just showing up in one column? There's a command called concat. Concat is an aggregate function for text fields. So what that means is aggregate means it's going to combine what's ever in the parentheses into one column. So here I've got select. This is exactly like I did before. Select from customer, last name, first name. But here I use concat and in parentheses. I did last name. I put a comma there and I put single parentheses, comma, space, single parentheses, and then comma and then first name. Now, notice how these words are blue and this stuff is red and other stuff will be green. Okay. Anything in blue is a command. Anything in red is something that's been quoted out. It's in quotes, which means anything within the single parentheses that's red is going to show up on the screen when you run the query. Please keep in mind that when we're doing this, we never use double quotes. Now, I think MySQL actually allows you to use double quotes for this, but every other database engine doesn't. So it's a single quote situation. So last name, comma, single quote, comma, space, single quote, comma, first name from customer, and someone's gonna do this. So I run that, and I've got it. Mary Smith, Johnson Patterson, Patricia, William Linda. There we go. Everything's in one column, but it's got this really weird name, and the name that it has is what I asked it to show me. And I don't want to see that because remember, this is going to the customer and they're not going to understand what concat last name, first name is. So what I can do is I can give the column an alias and I can say, select this as customer. And when I run this, the column will be called customer. Okay. I also have a clause down here called the order by clause. Order by clause lets me put whatever the results in the order that I want. So you have order by customers. And the reason why that's going to happen is because I've named that column customer. Because there is no column customer here, right? But I can order by customer because I've given this query that alias. And it doesn't matter that it's the same name as the table, it understands. So I run this and it orders it for me. I could just do order by last name and get the same results. But it's important to know that you can call this result by this name in any clause. Okay. Now I'm doing the same thing here, except I've added another column. I'm selecting the store ID, the customer column from customer ordered by last name. I run it. And now I've got the store ID and I've got that there. Now, when I do my order by, I've got two commands I can use. I can do descending or ascending. Descending is from Z to A, or from the highest to the lowest. Ascending is from 1 to the highest, or A to Z. By default, it's ascending. So you don't have to put ascending there. But if you want descending, you've got to put descending. Okay. I can order my column, I can order my table by more than one column. So here, I'm doing the same query here, store ID and the concatenation of the name for as customer, and ordering it by store ID, ascending by default, and then last name descending. So when I run this, I have store ID 1 with Cynthia Young, and then I go down here to where 2 starts, and here's 2, starting with Marvin Yee. I could change that to ascending, and it'll be the same thing, but it's important. The reason we bring this up is because you can have multiple columns in your order by. It's ordered by this one first, then this, and then whatever follows. There, I might be jumping. I might get hit here. There is a way, and I don't like doing this. You can do this with the order by 1 and 2. And this is just basically saying order by the first and second column in the query. This used to be a thing a long time ago. I don't know why we still do it or why it's still talked about. There is a question on the quiz about this. And again, all it does, it's cardinal. It's a cardinal reference. It's a cardinal reference, meaning 1 is first position, 2 is second position, and subsequently 3, 4 would be there as well. If I'd put 3, 4 here, it would error because there are no 3 and 4, 3/4 columns. Okay. So like I said last week, and remind you now, every time we write these queries, it's just adding another layer to a select query is always just select from. And we can just add stuff to it. Like we can add a concatenation of columns. We can add an order by clause. We can also add a where clause. So in this case, I've got select, the same select query as before from customer, but I've added where the last name equals Miller. Okay. And then order by store ID and last name. I do that. I have one person named Miller. So I've got my select query that tells me what I want to see. My from query, where I want to see it from. My where query, how I want you to filter it, and my order query, how I want you to sort it. So my question for you at this point, if you remember last week, I said that we refer to databases as engines because they're constantly running. So kind of a digression in the conversation is that whenever you run a query against the database and get data, you're taking that data off the hard drive and putting it in memory because you cannot manipulate or look at or touch or do anything with data that is on the hard drive. Do you understand what I'm talking about? Does that make sense?
Yes.
Okay. So when I run this query, it takes whatever I had there from the hard drive and puts it in active RAM. This is important to remember because when you're looking in terms of large databases with large result sets, it is completely possible to write a query that the results exceed the amount of RAM that exists on your computer. And then all sorts of shenanigans happen. So that's why when you write select queries, it's important to realize how much data is coming back. Okay. So when I run this query, it converts this code into machine code and then runs it in a specific order. So here's my question. When I run this query, which of these four commands is run first? Does it do select first, from first, where first, or order by first?
I thought it was from,
Exactly, the from clause. So what happens when you run this query, the first thing it does, it takes the entirety of the customer table and pulls it into RAM. So if the customer table is a terabyte big, you better have a terabyte of RAM. It pulls it all in. What's the second one that it does?
it's select.
No, where first.
Oh, where?
And reason why is
Oh,
because
yeah.
this where does not have to be in the select cause column.
Yeah, that's right.
So what happens is it does the where and it looks for that first and then gets rid of everything where it's not, because what the select does, it gets rid of the columns that it's not using.
That's
So
right.
from where select order by is the order that goes in. Does that make sense to everybody?
Yeah, yeah, makes sense.
And this is, I mean, and that's the interesting thing about how databases work. Because it's got to pull it off the hard drive, it literally pulls everything. If you're joining two tables, it pulls everything from both tables in there. Okay. So from customer, where, show me the columns that I want, and then give me the order. 1, 2, 3, 4. Okay. Now with this one is the same query as here, except I have this here. So let me go back here for a second. Okay. So when I'm using my where clause, I have where last name equals Miller, right? Oh, I'm not really. I'll do this later. Okay. So here I've got where last name not in, and I've got this subquery, and this is called a subquery. Okay. So I've got two commands. I've got in and I've got not in. Okay. So when we're looking at where clauses with in or not in, this is what's termed as an array or a set, right? It doesn't have to be a subquery. It can just be random names that you put in there. But we talk a lot about running subqueries in here, right? So here I've got where last name not in, and I've got this subquery of information that I have it looking from. Okay. And then an order by. So the difference here is this. We don't equal Miller. We're not in this. So now, when we're running subqueries, the first thing that happens is from actor is run. And then where last name, and then this select, and then customer, and then this, and then this, and then this. Okay. So this query pulls all the results from two tables into memory, all in a matter of seconds. And by the way, this from the time I hit this to the time the result set shoots out is how long this stays in memory.
I have a question. When it's pulling it out of memory, does it filter out what it wants before it puts it in memory, or do we have to take into account the entire table
You take out
regardless?
you take out the entire table regardless. You cannot manipulate any data that's on the hard drive. Everything has to
Even viewing or
be.
okay.
Yep. Even if you're running a simple select query, that pulls it in. Think of it as like everyone has that one drawer in their kitchen called the junk drawer, right? And if you need to go in there and see what's in there, you can't. It's way easier to pull everything out and put it on the table than it is to look through it in the drawer, right? So that's what this is. Or like if we're talking like old days, I go to the filing cabinet, which is my hard drive, and I pull out the folder that I'm looking for, and I bring it over to my desk and I open it up and I pull everything out from the folder, from the Johnson file, right? So it's the same way on computers. I
It's
cannot
just not memory efficient. So
it is memory efficient if you build the database right. Um, because a hard drive is static and can't change. So it's frozen stuff. So nothing can be, you can't look at anything on there. It's just there. You have to pull it out to be used. That's when we start talking about designing databases and building tables. You have to build them in such a way that they are efficient. And when you pull them into your hard drive, into your RAM, um, they don't cause a lot of problems. Plus, again, it's there for microseconds. It's not a super long ton of time. So I would have thought at some point in time, because a lot of drives are solid state now, that would have changed. But you still have to pull it into active RAM. Um, the only time it doesn't make a huge difference is if you're not doing anything. If this one here is not impactful on the RAM at all, it's just there and done. When you get stuff like this, it takes a little more time. But again, we're talking 1 or 2 microseconds. And you'd be surprised when you see like big complex queries that like 50, 60, 70 lines, they take 1 or 2 microseconds. So the efficiency in databases doesn't come from, well, it comes from both. It comes from the query, but it also comes from the tables and the index structures. Does that make sense?
Yeah, I was just thinking about large amounts of data. So yeah.
I in my day job, I've got databases that have tables in the terabytes that run queries all the time. So and we have terabytes of data. We have terabytes of RAM. Now, if you pull in more data than are you all familiar with the term paging when it comes to memory and hard?
No.
So if you have 200 gig of RAM in your computer and you've got 20 terabyte hard drive, right? Um, and you pull in 250 gigs of data, what's going to happen is it's going to put part of the data that you're not using on the hard drive and then just start swapping it out. So, like in this case here, when you've got actor and stuff like that, it'll run this and then move this to the hard drive in a little special paging area and then run the rest. So it's not the best way to run data on it because you're talking from the hard drive to the RAM back and forth, but it works. Um, and it seems like it's not efficient, but when you start playing with when you pull in large data sets, it runs super quick. It's when the indexes are bad or the query is bad that you start having performance issues. I don't really, it's hard to show that here because these are teeny little databases and I can't show you anything significantly large because I don't have the system to do it, but it's how it works. All right. Cool. Yeah, and paging is bad in databases. You never want that to happen. Okay, so here we were. Okay. All right, so we got the in and not in. So here we got this one does the same thing as this one does, except we don't have the big fancy query. So I have same thing, but show me what the last name's in Miller and Smith, and I run that, and it shows me the ones there are. If I use not in, and I run this, I think you're the first person in any course that ever mentioned memory efficiency in queries. So good for you. I wish I could give extra credit. I'll find a way. Um, and then not in says show me everything that's not Miller or Smith. So I have the other bunch of rows here. Okay.
I accept extra credit.
Huh?
I accept extra credit.
I have yet to figure out how to do extra credit here. Like you maybe like you like you have the bonus. You can skip a paper if you don't want to. Just let me know and I'll give you the credit for it.
Just kidding.
Um, I miss live classrooms and actual curriculums because I miss like that. I used to teach high school, and they never understood. I would give like 500 points extra credit. They never realized it took 10,000 points to do anything, but they just loved getting like 500 points. It was like a huge thing for them. Um, it was fun for me to do. Anyway, sidebar. Okay, so here next, my where clause, where last name like. So when I use equal means it has to be exact. In means it has to be part of the set that's there. Like means it has to come close to what's here. So here I have where it's like D percent sign. Percent sign is a wild card. So what this is, show me anything where the last name starts with D. And I run it, and there you go. If I take and put it there, show me any last name that ends with D. And there we go. And then put one on both sides of it. Show me any last name with a D in it. And there you go. There's one there. There's one there. Doesn't care. Just doesn't care where it is. Just as long as there's one in there. So we can use variable strings to get data out. Did I do that here? No. So I go here. Let's go. So I can do this. So let's do this. I can do where it's starts with a D. Let me see what I got here name wise so I can make so it's gonna return something. Oh, just show me where percent is. Show me where anything is. So okay. So show me where a D, and I use an underbar to say there's going to be a second letter, and then show me where the third letter is an L. So this is, and then I don't care what's after it. So first letter is a D. I don't care what the second letter is. Third letter is an L, and then I don't care what's after it. Why would you do this? I don't know. It's a fun party trick. Um, there are a lot of things that, and this is just under. I think. Well, I know why. We do this to show you the granularity you can get out of a where clause. You can get really super granular. Um, as long as you got a good reason to do it, that's cool. Don't do it just for fun. I think I've been a DBA for 22 years. I've never done something like that in a production database. Here, next one. I've got changing to the film table. I'm using title and description. And here I've got where description like docu or description like cow. So wherever the description column has these four letters in it or these three. And so I've got two choices, right? Or and I've got and. Or means one of the two criteria must be met. And means both the criteria must be met. So if I run this one, documentary. So this one's got docu. These are all the docu. And there's one with a cow. And there's with the cow. And the documented with the cow. So if I go here, the and, a fanciful documentary of a frisbee and a lumberjack who chased a monkey. No, there's why are we doing? Where's cow in here? It's and. Somewhere near there's cow.
Can I bug you with another question?
Sure, go ahead.
Is there a limitation to how many subqueries you can have inside of each other?
That's a fantastic question. Again, no one's ever asked that question. The answer is yes, and it depends on the system that you're using. With MySQL, the limit is 4. With Microsoft SQL Server, it's 8. And I don't know what it is for Oracle. It's not a hard and fast rule. If you have 9 there, it's not going to fail, but the query will never return.
Okay.
It's best not to do more than 2, because anything more than that is going to cause problems with the engine. But yeah, you can go up to 8 subqueries in one query.
Can you create views or temporary tables instead? Is that kind of
Yeah,
okay?
using temporary tables.
Yeah.
We don't talk about temporary tables here, but we bring up the last chapters about views. If I scare my code, I'll show you guys how to do temporary tables one week. I have to scare my code for it. It's because like I told you last week, every engine uses Transact SQL, but it's like going through Germany and speaking German along the way. There's different dialects across the road everywhere. So Transact SQL for Microsoft SQL Server is not the same Transact SQL as Oracle because there's differences. and it's not the same as MySQL. There's words that are code. There are commands that are missing. There are commands that do different things. There are commands that are called like Alex. As we go along, I'll point some out. But these are all the same, but it does get a little confusing after a while. Like for example, in MySQL, this is does not equal. Sorry, this is does not equal, and it can be attributed to anything, numbers, text values, whatever. In Microsoft SQL Server, that will only respond to text files. It won't do numbers. It'll throw you an error if you try to do that. The inequality for numbers is that the alligator's kissing, right? So, oops. All right. So, um, yeah. So here's where descriptions like docu and description like cow. Oh, not like cow. That's why it's not coming through. So here I go description like cow, and now I've only got these documentary of mad cow and womanizer, mad cow and a pioneer, documentary, blah blah blah, right? And I can do a not like here. I hit the insert button. And now it'll be this here. Right. All right, there's the 1, 2, 3. So that pretty much ends the code that this will get you through this week and next. As far as coding is concerned. So does anyone have any more questions on these the select queries, how they work, the where clauses, how the order by clause works, anything about the previous assignment for last week or the website one for this week? All right. Well, then
She
I
we'll.
had a
didn't
question
hear.
about the writing assignment at the end.
Oh, this week there is no
No,
writing.
like even last week, but the writing assignment, are they looking for us to like identify this is what a select and or how much detail is wanted in that?
So the writing assignments, we talked to the course designer last week, myself and one of the teachers, and we're looking to change the writing assignments because neither of us really like them. But yeah, so they want you to deliver as much information as you can or you feel is necessary on the topic. Are you thinking about doing the final project?
Oh yeah, I'll do a final project
Yeah.
for sure.
So if that's the case, and like I said, if you do the final project, then the writing assignments change.
But
So
we have to do the writing assignment each week through week 7 still too, right?
nope. If you do the final project starting next week, here, let me see here. So let's look at next week. Give me my courses, give me my thingy here. Um, okay, so I'm gonna go to module, go to week 3. Okay. So if you choose to do the final project versus the final assignment, the final test, as of next week, you ignore this and you don't give me that paper. As of next week, the writing assignments are Brother Stevic, here's where I'm at on my final project. And that's all it is. It's not 5 paragraphs, it's just a quick note to me, hey, I'm thinking about these 3 possibilities for database. What do you think? Here's what my ERD is. What do you think about that? Here's my first query. It's just a communication with me to tell me what your progress is on the final paper. Final.
Okay, so just this week we do it as a case study.
So this week is not a paper. This week is a video assignment.
Okay.
So this week is the reverse engineer a website. We talked about just before you got on. So for this week, all I want is a 2 to 3 minute video with your camera on where you look at a website and like this one here and kind of tell me what you think the backend database looks like. I don't need you to draw it or do any kind of diagramming. I just need you to talk me through what you think it looks like. The purpose of this assignment is to get you used to the idea of talking about databases. talking about what tables are and what tables might be there and how they might talk to other tables and things like that. This is not a to take it and design it from the ground up. This is just talk about it for me. And the reason we do this is one, for me to gauge where your knowledge of table, what databases are, what you know about the pieces that go together. And the other is to invalidate the need for us to use Proctorio. Because with online classes, you're required to have one assignment where you have a camera on and you prove who you are. This takes care of that.
Sounds good.
Yeah, we used to have like quiz 6 and 11 had to be done with Proctorio, and they let us do this instead, and there was much rejoicing when that was approved. So yeah, the only way to fail the week 2 paper is to not turn your camera on, and not talk about a database. So it's just the way it is. So it's very, very simple. And anyone who doesn't pay attention and doesn't watch the videos and just goes to get the assignment is going to turn in a 10-minute video to me, which will make me sad because I have to watch a 10-minute video. Um, but yeah, so like you wouldn't write this, you wouldn't talk about your boss gave you a new task this week. You should learn how to explain the various filtering techniques of where clause. Um, yeah, so you have to like talk about this stuff and answer the question completely in 5 paragraphs. I think the final project is a better thing anyway. So yeah. So if you do the final project after this, like next week's paper is just, hey, these are what I'm thinking about for topics for the database. And
Sounds great.
next week's Tuesday night, we're going to talk about the final project in detail, like what to expect, what to do. Don't read the assignment as it's printed there because I do something different.
Thank you so much.
Oh, no problem. Thank you for all the questions tonight. I love questions. Any more? Anything else? No. All right. Well, I'm gonna end class 14 minutes early because it is 10:16 here in Florida. And I gotta get up at 5 a.m. for seminary. So thank you all for coming. I'll go ahead and get the transcript down, put the video up, and if you have any questions, just email me or text me and I'll answer what you need.
Thank you so much. Have a good night.
Thank you. Bye, guys.
Thanks.
Bye.
Bye.
Bye.